Welcome to Brain Vision.
This question is a setup about cathode ray tubes in computer monitors, and then we have an electron um, with initial speed 6.5 times 10 to the 6 meters per second. Okay, and then the lower plate is at a higher potential, so here's plus V 0. We know that the electric field is going to be pointing up. Okay, but the electron will experience a force downward. Okay, yeah, because the bottom plate is at a positive potential, at a higher potential. So okay, so in this question there are 5 parts, uh, asking about force, acceleration, the vertical deflection, the angle with the axis that it exits the plates, and vertical displacement when of the electron when it strikes the screen. Okay, so there is a reference line that you need to work with. Okay, this is a horizontal line that the electron enters the parallel plates. Okay, so in part A we need to find the force. Okay, so we'll be using F equals to QE. Okay, this is the relationship between force and electric field, and then in parallel plate situations we have E equals to delta V over D. Okay, so the magnitude of the force is Q V over D. Okay, 1.6 times 10 to the negative 19. V is 22, and D is 2 cm. Okay, so 0.02, calculate this to be 1.76 times 10 to the negative 16 newtons. Okay, so this is the magnitude of the force. Okay, the direction is downward. Okay. Okay, next in part B, you want to find the acceleration. Okay, so using F net equals to ma. Okay, so A equals to F net divided by m. Okay. Okay, put in the numbers. You calculate this, you get 1.93 times 10 to the 14 meters per second square, and then the direction is also downward. Okay, follows the direction of net force. Okay, in part C, you want to find the vertical displacement when it reaches at the end of the plate. Okay, so we need to find the time taken for the electron to exit the plate. Okay, to find this, okay, we need to find the time, then we will use the kinematics equation to find the vertical displacement. Okay, so this is the horizontal displacement divided by V naught. Okay, so you get 0.06, which is 6 cm, divided by 6.5 times 10 to the 6, and you get 9.23 times 10 to the negative 9 seconds. Okay, so this is the time for the electron to exit the plate. So the vertical displacement okay, using the kinematics equation, delta y equals to V naught y t plus half ay t square. Okay, so the V naught y is 0. Okay, a naught y, ay is something, is the answer in part B. So delta y is half ay t square This is equal to half times 1.93 times 10 to the 14 times 9.23 times 10 to the negative 9 square. Calculate this, you get 8.23 times 10 to the negative 3 meters. Okay, so 8.23 mm. Okay, then we want in part D, we want to find the angle, the angle of the angle that the particle exits when it exits the plate. Okay, so in this case, we need the vertical velocity. The vertical velocity at exit. Okay, this is equal to ay times t, 1.93 times 10 to the 14 times 9.23 times 10 to the negative 9. Okay, you calculate this, you get 1.78 times 10 to the 6 meters per second. Okay, so at the as it exits the plate, okay, the particle is moving like this. It has a vertical component. Okay, and then this is the angle that we are looking for. So the angle is arctangent Vy divided by Vx. Okay, the Vy is 1.78 times 10 to the 6. Vx is 6.5 times 10 to the 6. Okay, if you calculate this, you get 15.3 degrees. Okay, but at the same time, it has already moved downward. Okay. By 8.23 times 10 to the negative 3 meters. Okay. Okay, then in part E, we want to find the distance below the axis when it strikes the screen. Okay, so so the particle will continue to travel in this velocity. Okay, so this is going to follow this trajectory. Okay, this is 15.3 degrees, while it has already traveled downward 8.23 times 10 to the negative 3 meters. Okay, so there are a few ways. Okay, there are a few ways to do this question. You can use trigonometry to find the distance below. So this top line is our axis. Okay, but this is the trajectory when the particle exits. Okay, so we can actually calculate this distance, right? So let's say we call this delta y2. Okay, so tangent 15.3 degrees is equal to, from the diagram, delta y2 divided by 12 cm, so it is 0.12. Okay, so delta y2 is 0.12 times tangent 15.3 degrees. Okay, so if you do this, okay, then you get 0.0328 meters. Okay, then the distance below the axis is equal to 8.23 times 10 to the negative 3 plus 0.0328. Okay, then you get 0.0411 meters. Okay. Okay, so this is the answer for part E. Okay, and that's all for this question.